Hi, my peeps. I wanted to make a video on how to solve reducible equations. We want to reemphasize some of the things that we talked about in class. So here is an example from this homework set on section 3.2 entitled Quadratic Formula and Reducible Equations. So we have the equation x to the fourth plus 4x squared equals 60, and we are asked to solve this one. X to the fourth plus 4x squared. All right. Equals 60. Remember, with reducible equations, the goal is to make a substitution for the variables so that we can change the format and make the new equation look like a quadratic. Here we have a power of 4, a degree of 4, so this is really a quartic, but we want to reduce it and make it look like a quadratic. As we discussed in class, an easy way to figure out what you want to let your u substitution equal is to look at the second term. It's an x squared. So we are going to let u equal x squared. Remember, x to the fourth is the same as x squared squared, because our properties of exponents tell us when we have a power raised to another power, we multiply those powers to get the final simplified answer. So the only reason I'm doing this is to illustrate to you why this substitution method works. So now we want to substitute everywhere that we see an x squared, we want to replace it with u. So we have an x squared here. We want to replace it with u. We have an x squared here that we want to replace with u. The x squareds are replaced with u. So the resulting equation would be u squared plus 4u equals 60. And now we have a quadratic that we can solve using any of the methods that we prefer. So I'm going to go ahead and write this in standard form. Remember, standard form, your powers are decreasing, and then we want to set it equal to 0. Okay? So I need to subtract 60 from both sides of the equal sign so that I can set this quadratic equal to 0. When we do that, we'll end up with u squared plus 4u minus 60 equals 0. So now we'll solve this quadratic. Let's go ahead and use, well, we can see if it's factorable. And also we can use the quadratic formula if it's not. Remember, the quadratic formula works all the time. Factoring only works if the quadratic is factorable. So just to review factoring, we're going to take, let me see, factoring. We're going to take our leading coefficient, which is an invisible 1, and we're going to multiply it by the constant, which is this negative 60. 1 times negative 60 is negative 60, and now we want to list the factors of negative 60 and see if any of the factors will give us our middle coefficient of positive 4. So the factors of negative 60 are obviously the 1 in negative 60, negative 160, negative 6 positive 10, positive 6 negative 10, and we could keep going, but hopefully now you see which factor pair or combination will work. These will work because -6 plus 10 gives us the +4 that we want as our middle coefficient. So now we can set up our parentheses. We will have a u minus 6 times a u plus 10, and it equals 0. We don't have to do bottoms up because our leading coefficient was a 1. So this is the factored form. What does this mean? Remember we talked about 0 multiplied by any number is 0. So if either one of these factors is 0, then our product would be 0. So now that is why we then set each factor equal to 0. U minus 6 equals 0, and u plus 10 equals 0. And we're going to solve them. Add 6 to both sides, and we find that u equals 6. Or subtract 10 from both sides, and we find that u equals -10. Well, what is u? If you remember at the beginning of our process, we decided that we were going to replace all the x squareds with u. So now we have to come back in and undo our substitution. U really is x squared. So x squared equals 6. We need to use the principle of square roots to solve for x. The inverse of squaring is taking the square root. So we want to take the square root of both sides. And remember, because we're solving a quadratic and we're taking the square root, that we have to include one answer is positive, one answer is negative. Okay? The square root symbol and the square cancel, and we're left here that x is either going to be a positive square root of 6 or a negative square root of 6. That's just 2 of our solutions. The original function had a degree of 4, which means we will have 4 solutions. All of them don't have to be real number values because now we're operating in the complex number system. So let's go over here and let's figure out the other possibilities for x. Again, u is x squared, so x squared could equal -10. We're going to undo the squared by taking the square root of both sides. And that tells us that x equals plus or minus the square root of -10. And we can't find a perfect square that will go into 10, so we're going to leave it, but we are going to bring out, or remember that the square root of a -1 is I, okay? So we're going to bring out an I from underneath the radical sign to get rid of the negative in front of that 10. So here's what it would look like. X would equal a positive I square root of 10 or negative I square root of 10. I'm just trying to make my screen bigger, y'all. There it was. Anyway, I don't have time for that right now. I'm just going to squeeze the 10 in right there. Hope you can see it. So our solutions, our 4 solutions are positive or negative square root of 6, positive or negative I square root of 10. Those are our 4 different solutions to this reducible quadratic. And so let's go back to the original question and see which answer choice it was. Your textbook writes their I after the radical, And I don't really like that, but it's not my book. I don't like it because sometimes students who don't see very well would think that that I is underneath the square root symbol. It is not, okay? But at any rate, we know that based on the work we've done, our answer choice is going to be number A, letter A. And that's an example of a reducible quadratic.